today. This question is related to theme D in physics higher level, which is fields, and this is subtopic D.1, gravitational fields. So the question says the following statements are given about the forces acting on a satellite in orbit around a planet. And the three statements are gravitational force on the satellite is proportional to the mass of the planet and the mass of the satellite. The strength of the gravitational field is equal to the weight of the satellite, and the centripetal force acting on the satellite is provided by the gravitational force between the planet and the satellite. Which of these statements are correct? Okay, so let's go through each of these one by one. So the first statement says the gravitational force on the satellite is proportional to the mass of the planet and the mass of the satellite. So we know Newton's law of gravitation says that F equals g m1 m2 over r squared. Now, m1 here would be the mass of the planet, so that is correct. Force is directly proportional to the mass of the planet. And m2 would be the mass of the satellite, which once again is fulfilled. So that means statement 1 must be correct. Now, statement 2 says that the strength of the gravitational field is equal to the weight of the satellite. Alright, so let's think about this. The strength of a gravitational field would be the acceleration due to gravity. So let's just assume that there's a satellite orbiting Earth. We know that that F equals mg for this satellite, where g would be 9.81 meters per second square on Earth. So if we just assume that it's going in a circle, or whatever shape for that matter, but a circle would just be the easiest, the strength of the gravitational field at that point would be 9.81 meters per second. But this says is equal to the weight of the satellite. The weight of that satellite would be mg, or the mass of the satellite times the strength of the gravitational field. So unless the mass of the satellite is actually equal to 1 kilogram, then the weight of that satellite would not be equal to the strength of the gravitational field. So we know that statement 2 is completely wrong. Now, statement 3 says the centripetal force acting on a satellite is provided by the gravitational force between the planet and the satellite. So let's just imagine a satellite here orbiting outer space in a planet. So what forces could possibly act on it? There would be no normal force because it's not touching anything. There would be no friction because we assume that everything is ideal, so there would be no friction that would be slowing down the motion of the satellite. The only force acting within this ideal gravitational field would be the weight force exerted by the planet on the satellite, and we would also have a negligible pull from the satellite, which would pull the Earth towards it, but that is quite negligible. So this would mean that the only actual force acting upon the satellite would be the gravitational force between the planet and the satellite. So the centripetal force can only really be provided by the gravitational force because there is no other force to provide the centripetal force. So that would mean that the answer to this question would be option C, 1 and 3. I hope you found it helpful, and see you next time.